Have you been doing Riemann sums all day long, and are you getting tired of those rectangles? There's gotta be a better way! Well, I'm here to tell you that there is! Trapezoids! Except I deleted the E! But it's back now, no worries. To review, before we get started, trapezoids are these quadrilaterals, meaning they have four sides. And the thing about them is that they've got two sides that are parallel. The area of a trapezoid, if the base we call delta x, and we call one of the sides B1, one of them B2, the area is 1/2 delta x B1 plus B2. This is kind of like area equals base times average of the height, so base times height would be area. The idea here is that if we're trying to find an area, while Riemann sums do it with rectangles, we could instead use trapezoids. And just like with rectangles, the more that we use, the better our approximation will be. So let's give it a try. Say I've got this function, and I'm trying to find the integral from 0 to 3. I can approximate this area using three equally spaced trapezoids. They don't have to be equally spaced, but this problem uses the phrase equally spaced. So I do one between 0 and 1. If I'm going from 0 to 3 with three trapezoids, I'm going to go 0 to 1, 1 to 2, and 2 to 3. So my first trapezoid will go from 0 to 1. My second will go from 1 to 2. And my third trapezoid will go from 2 to 3. Pretend like these are lining up with the actual points where they should. It's not bad. The area I'm looking for I can approximate by finding the area of each of these trapezoids. This first trapezoid, its area I get by looking at its base and looking at the height of the two parallel sides. The height of this side is going to be whatever the y value of this point at the top is. My area is going to be 1/2 delta x. My first side we said has a height of f of 0. This side has a height of f of 1, because that's where this point lines up on the y-axis. So the area of this first trapezoid is 1/2 delta x f of 0 plus f of 1. My second trapezoid has an area of 1/2. Its base will be the same delta x. I split it into three equally spaced. I split my whole area into three equally spaced trapezoids, so they all have the same width on the bottom. The height of this side is going to be whatever f of 1 is. The height of this side is going to be whatever f of 2 is. And my third trapezoid will be similarly 1/2 delta x f of 2 plus f of 3. My integral that I'm trying to find, I can approximate this integral by adding up these three areas. If I add up the area of the first trapezoid, the second trapezoid, and the third trapezoid, I get 1/2 delta x f of 0 plus f of 1 plus another f of 1 plus f of 2 plus another f of 2 plus f of 3. So it's 1/2 delta x. In this case, I went from 0 to 3. That's a width of 3. I split it, that length of 3 into 3 pieces, so each piece has a length of 1. Delta x is 1. F of 0 was 9 plus 2. F of 1 is 6. I'm just reading these off the graph. I'm not actually calculating it. I'm just seeing what the point is. F of 2 is 3. In other words, I could be wrong if I'm not reading it correctly. F of 6 looks like, F of 3 looks like it's 6. So this is going to be 1/2 times 1 times 9 plus 12 is 21, plus 6 is 27, plus 6 is 33. It looks like I come out to 33 over 2. 33 over 2 is my trapezoidal approximation of this definite integral using 3 equally spaced subintervals. Oh goodness, oh my, I'm lightheaded. That was such a breathy sentence there. Let's try another. By the way, before we get there, this pattern that happened here, where I used the y value of my real endpoints of f0 and 3, and I used the y value of all my spots in between, but I had to double it. That pattern happens every time. Every time I'm going to get f of each little number along here. I'm going to do f of 0, I'm going to do f of 1, I'm going to do f of 2, and I'm going to do f of 3. And each time I'm going to have to double the ones in the middle, all of the ones in the middle, but not the ones on the end. I double everything except for f of 0 and f of 3. And I always multiply in front by 1/2 delta x. So I could find each individual trapezoid, or I could know that's the pattern overall, and that pattern overall will save me some time. Moving on. Here I am looking at the graph of square root of x, and I'm going to be approximating the area under it between 1 and 16. I'm breaking it into 3 equally spaced subintervals. So that's a length of 15 that I'm breaking into 3 pieces. Each piece will have a length of 5. My delta x will be 5. I'm doing area under square root of x, and I'm breaking this area, which I'll lightly do a half-hearted attempt at shading. I'm calculating this area. I'm estimating it by thinking about 3 trapezoids. It's not always 3, and it's not always equally spaced, but in this case, 2 problems in a row, it was equally spaced, and it was 3 of them. My first trapezoid will go from 1 to 6. Then I've got one from 6 to 11. And then I've got one from 11 to 16. The first trapezoid has a base of, I'm just going to call it delta x for now. I can see it's 5. From 1 to 6 is a length of 5. I'll call it delta x just so I'm, I don't know, a little formulaic. The height of this side is f of 1. The height of this side is f of 6. So the area of my first trapezoid is 1/2 delta x f of 1 plus f of 6. The area of my second trapezoid is going to be 1/2 delta x f of 6 plus f of 11. The area of my third trapezoid will be 1/2 delta x f of 11 plus f of 16. If I add up all 3 of these areas, adding them all together, if I add up all 3 of these trapezoids, it'll give me a good approximation of this definite integral. Adding these up, I get 1/2 delta x f of 1 plus 2f of 6, 2f of 11 plus f of 16. So 1/2 delta x is 5 in all 3 cases. It was equally spaced, so in all 3 cases the width, like 11 to 16 for instance, is 5 units long. So 1/2 delta x f of 1 plus 2 f of 6 plus 2 f of 11. I'm calling this f. Nowhere, I never defined f to be square root of x, but I hope that you have the common sense to know by f. I did it again. By f, I mean this function. So it looks like I come out to 1/2 times 5 plus 2 root 6 plus 2 root 11. If I care about simplifying, which maybe I do, maybe I don't, I get 25 halves plus 5 root 6 plus 5 root 11. Again, I see this pattern where I did f of each single number from every little subinterval. I did an f of 1, I did an f of 6, I did f of 11, I did f of 16, and the ones that didn't have 2's were f of 1 and f of 16, the ones on the end. Everything in between had a 2 in front of it. I added them all up, and in front I multiplied, or in back where multiplication commutes, somewhere I multiplied by 1/2 delta x. From now on, I'm just going to do this thing with the 1's and the 2's, and I'm not going to do individual trapezoids. So for 1 over x, for instance, I'm going from 2 to 18, and in this problem it asks me to break it into 4 equally spaced subdivisions. From 2 to 18 is length of 16, broken into 4 pieces. Each piece has to have length of 4. So I go 2 to 6, 6 to 10, 10 to 14, and 14 to 18. I'm going to think about this as a bunch of trapezoids, but really I can stop thinking about it as trapezoids, and if I want I could just think about it as a formula. Trapezoid approximation ends up being this formula where I do f of each number that's an endpoint of one of my subintervals, and the ones in the middle I have to double. So everything in the middle I double, but whereas f of 18 and f of 2 I don't double. And adding up all these heights, I have to multiply by 1/2 delta x. In this case, my delta x is 4. From 2 to 6 is 4, from 6 to 10 is 4, from 10 to 14 is 4, 14 to 18 is 4. The reason it's 4 is because I went from 2 to 18. So I went a distance of 16. I did it in 4 moves, so each one had to be 16/4. Each one had to be 4 long. That's my delta x. In general, it's b minus a over n, where n is the number of subintervals. Anyway, my trapezoid approximation for this is 1/2 4 f of 2, 2 f of 6, 2 times f of 10, 2 f of 14, f of 18. If you're the type of person who likes to simplify, my gift to you, Merry Christmas. You may simplify. I hope I don't lose any of you by saying Merry Christmas. I hope you know very well that that is a joke. This last one, just like with Riemann sums, maybe I don't have an actual function, maybe I just have a table, but I do it the same way. If I want to approximate this, where I'm going from 2 to 10, and I'm doing it in 4 subintervals, so 2 to 10, that's a length of 8. 8 broken into 4 pieces. Each piece must be 2 long, so I go from 2 to 4, 4 to 6, 6 to 8, and 8 to 10. Riemann approximation says I do f of each of these. Not Riemann. Trapezoid approximation. Riemann, I would also do f of many of them. Trapezoid says I do f of each of these. I double all the ones in the middle, everything but the ends. I add it up, and I multiply by 1/2 delta x. So my trapezoid approximation is 1/2. Delta x in this case is 2. Between each of these, I took 2 steps. From 2 to 4, I took 2. 4 to 6 was 2. 6 to 8, 2, 2. F of 2 plus 2 times f of 4 plus 2 times f of 6 plus 2 times f of 8 plus f of 10. The 1/2 and the 2 cancel out, and I'm left with 17 plus 2 minus 4 plus 16 plus 7. 17 and 2 is 19. If I take away 4, I'm down to 15, but then I add 16, and I'm at 31. Plus 7 makes 38.